We just said the integral of a product or quotient of functions is not the product or quotient of the integrals, at least usually. I wonder if you can ever find a case where it is. But anyway, what rule might you hope would be true? The integral of a product or quotient doesn't work out nicely. You might hope that the integral of a sum or difference would be the sum or difference of the integrals. So we can at least write out our hope here. Integral of a sum or difference. So can you go do an experiment with something where you can integrate each individual part of a sum or difference and then see if that seems to be the integral of the whole thing? So pause the video, go make up a function. Okay, welcome back. Here's a straightforward one, I hope. So integral of 2x plus 4x cubed dx. Remember I said when you put the dx there, it really is a multiplication, and we really do want to multiply it by the entire function here. So really we should put parentheses like that. Sometimes we get sloppy and don't. So what would we hope this is? You would hope that you could break it into a sum or difference. So integral of 2x dx plus integral of 4x cubed dx. Now when we broke the integral of a product into the product of the integrals, which again did not work out, but we were a little unclear, like should I copy the dx and put it out here? But here it's pretty clear that yeah, I do. I'm not just copying because this dx is also multiplied by the 2x. So that feels like we're on a little bit more firm ground. What's the integral of 2x? Hopefully you've seen us do that before. X squared plus c. What's the integral of 4x cubed? What function, when you take its derivative, is 4x cubed? That would just be x to the fourth, plus some other vertical shift that we don't know, but we can't use c because that's the vertical shift for this one, right? So we might use capital D. But then it seems weird to say I have two vertical shifts I don't know, like maybe this one is 3 and that one is 7, or maybe this one is 2 and that one is 8. Either way, they would both add up to 10. So what we usually do in a case like this is combine them into just a plus c, unless you have a strong reason to use some other letter. So we would actually just write x squared plus x to the fourth plus c. So is that the antiderivative of that? Well, we can check it. What's the antiderivative of, or what's the derivative of all that stuff? It would be derivative of x squared is 2x, derivative of x to the fourth is 4x cubed, derivative of plus c is plus 0, and we get the same formula we had there, so it checks. So in general we can say the integral of a sum or difference is the sum or difference of the integrals, which is basically the way it worked for derivatives, so no big surprise there, right? Another fun derivative thing was the power rule, right? So let's talk about that. So if f prime is equal to x squared, what is f? What's the antiderivative of x squared? Well, it should have an x cubed, but then we don't want to get a 3 in front when we take the derivative, so we put a 1/3 here, right? If f prime is x cubed, what's the original f? 1/4 x to the fourth. If f prime is x to the n, what would you say the original n is? In derivative rules, it would be n x to the n minus 1, but here we're going the other way. So the rule seems to be whatever I have here, add 1 to it in the power, and then divide by whatever the new power you just wrote is. Does that work with what we have so far? Okay, so the power rule for integrals is the integral of x to the n dx go ahead and write out what it should be. 1 over n plus 1, x to the n plus 1 plus c. All right, so take some time to remember when you're switching gears between taking derivatives and integrals. Do I add 1 to the power? Do I not? Do I write a fraction in front? Do I not? Is the number in the denominator of the fraction the same as in the power? Or is it off by 1 like it is when we take derivatives? Okay, so it takes some practice, and that's okay. Let's keep going with this. What's the integral of a constant? Well, what's the integral? Let's take the simplest constant. What's integral of 1 dx? What function, when I take its derivative, do I get 1? Just x. So you could say x plus c, or you could say 1 is x to the 0 dx. And what we got was x to the 1, and 1 over that plus c. How about the integral of something like 8 dx? What can you do with that? Well, you could write it as the 8 times the integral of 1 dx. So it'd be 8 times blah, blah, blah x plus c. And again, I wouldn't worry about whether you're multiplying the c by 8 or not. We generally don't get that careful with it. That would be a fine way to do it. What's the integral of 0? What's the integral of 0 dx? Well, can you write 0 as x to a power? Not really. X to the 0 is 1, not 0. What function, so actually this isn't part of the power rule, right? What function, when I take its derivative, is 0? Any constant, right? So it's just capital C.